Hey guys, we are going to look at linear models. So I know we've done a little bit about basics of linear, but now this is going to be more real world and other ways that we can apply this. So the relation between Celsius and Fahrenheit is linear. That is, we've got this basic equation that we can follow, and notice that this looks a lot like our y equals mx plus b. They just use different letters. So this is where our y would be equals mx plus b. So our input, our independent, is Celsius. Our output, our dependent, is the Fahrenheit. But it lines up just like our y equals mx plus b. We're told that 4 degrees Celsius corresponds to 39.2 and 10 degrees Celsius corresponds to 50. So what they've basically done, since the C's are X's and the F's are Y's, they've given you two ordered pairs, 4, 39.2 and 10, 50. So if that helps you to write them as ordered pairs, go ahead and do that. Now, we want to find the values of A and B. So in the terms that we're used to, the A is our slope and the B is our y-intercept. Now, I'm going to give you a couple of options when we go linear. So the first way I'm going to do this is just normal slope formula. So m equals y2, which is our 50, minus y1, which is our 39.2, over x2, which is 10, minus x1, which is 4. And then we can go to the calculator, and they give me a slope of 1.8. So in this case, my A is 1.8. Now, there's a couple of different ways to find B. The first way that I want to do is just working from y equals mx plus b. So if I start with y equals mx plus b, I already know my m. So I really know y equals 1.8 x plus b. The b is the thing that I'm missing and I want to find out next. So you have to take one of your ordered pairs, whichever one you like best, and substitute them for x and y. So this is one way to do this. So 10 is our x and 50 is our y. So 50 for y, 1.8 times 10 plus b, and then you could go to insolve, or you could actually solve this, and you get a b equals 32. So A and B are found. Now, another way you could do this is we've got two ordered pairs, so your calculator could do linear regression for you. It's definitely a good way to check whether your A and your B are right. You can just simply do linear regression. It's going to write the equation between the 2 points that you were given. Now on the next one, we've got a whole scatter plot. Now it does look very linear, so we could do a linear regression, but look, this is not what they're asking me to do. They're saying that if P equals AQ plus B, again, that's the same thing as our Y equals MX plus B, just with different letters, use 1015 and 2545 to find the best fit line. So the best fit line is different than our linear regression. Best fit is kind of just taking 2 points and eyeballing where it goes. So basically it's the same thing we did in example number 1. Find your slope, so m equals 45, which is our y2, minus y1, which is 15, over 25, that's our x2, minus x1, which is 10. And then I can go to my calculator and I get my slope as 2. My b value, I could solve it the same way I did in number 1, but I want to show you another way. So we have point slope, y minus y1 equals m times x minus x1. And some of you might prefer this way. Typically I default to this one. But it really doesn't matter. It's definitely preference on which way you like. So I'm going to go y minus whichever one of these I like better. I'm going to go with a 15 equals m, which I just found to be 2, times x minus 10. And then I can rearrange this because they just want it in y equals mx plus b, but using different letters. So y minus 15 equals, distribute this to 2x minus 20. Add the 15 to the other side, and we've got y equals 2x minus 5. Now, I wouldn't want to leave it with y's and x's. I would want to put my p where it goes, and then 2q where it goes, and then minus 5. So that's another way to find your b value. They're really about the same number of steps, so it's really a preference thing. You could also take these 2 points, like I said, and use linear regression, and you would get the exact same answer.